All right, today we are going to work on Unit 1, Lesson 12. And so on your screen, you will not see where it says this Unit 1, Lesson 12 Standard Deviation. I have it unpublished because I want you to click on Friday's agenda. Oh wait, let me go back. So we're on Week 3. So here you're on Algebra 1. Go to Week 3, Friday, and then Friday's agenda. And then today you will follow the link below for the Desmos activity for Lesson 12. So it's very similar to Lesson 11's activity, but we're on the next lesson, so you will click that, and it's going to take us to the Desmos activity. And it already has my name there. You would sign in with Google if it has you do that. If not, it may already have you signed in from yesterday. All right, so it said this is the cool down from the previous day. So we're going to go over this. A restaurant owner believes that it is beneficial to have different menu items with a lot of variability so that people can have a choice of expensive and inexpensive food. Several chefs offer menus and suggested prices for the food they create. The owner creates dot plots for the prices of the menu items and finds some summary statistics. Which menu best matches what the restaurant is looking for? Explain your reasoning. So they want different menu items with a lot of variability. Remember, that is a widespread, or the data is more spread out if it's more greater variability. And they want people to have a choice of expensive and inexpensive food. So this first one, for Italian, it goes from anywhere from $2 to $15. It looks like the data is kind of close together. Well, it tells you right here, the MAD is 2.45, the IQR is 350, so you can see that it's kind of low. So looking at the next one, the diner, you have the data is pretty much on the lower end. The median's $2. It's not a widespread of data. Looking at Japanese, we have anywhere from $2 to $33. The MAD and the IQR, which measures the variability, those look higher than these first two so far. But let's look at the steakhouse. Okay, so we have anywhere from $5 to $25, and it looks like that the mean absolute deviation is 369 and the IQR is 450. So looking at the Japanese, you can see that the MAD and IQR are both higher than all of the other ones. So the Japanese is going to be the one where the variability is greater than any of the other restaurants. So Japanese is going to be the one that's going to give you a more of a variety of inexpensive and expensive foods, and then it has a greater variability. So Japanese, and then the variability, whether measured with IQR or MAD, mean absolute deviation, is greater than any of the other menus available. So this gives you more items that are inexpensive and expensive, and then you can see that the data is more widespread with the Japanese menu. Okay, so if you need to pause and keep typing, go ahead. But we just wanted to go back over the cool down from yesterday. So this is just kind of a review. So we're going to move on. And now we are on 12.1. You have a notice and wonder. So you have these different dot plots here, and you have some summary statistics with those. So looking at all of these dot plots, type down one thing you notice and one thing that you wonder. So do that first. I want to see your responses. I can talk about some responses, but I want to see your responses, and then we can also talk about some things. So once you have typed yours, you can click next. You can see that all of these have the same mean. All of these data sets have the same mean of 10. You can see that mean absolute deviation and standard deviation are larger for some dot plots and smaller than others. This last one, the dot plot that has all of the data values on 10, it has a mean absolute deviation of 0 and a standard deviation of 0. That means there's no variability. All of the values were on 10, so the data did not vary at all. The standard deviation is always greater than the mean absolute deviation, except on this last dot plot when they were both 0. And things you might wonder, how do we calculate standard deviation? Do standard deviation and mean absolute deviation measure the same thing? Do they both measure variability? That could be something you could wonder, or you might have had something else. So I wanted to see your thoughts, but I also wanted to discuss this with you too. All right, 12.2 is what we're going to next. Now this is a little bit tricky because we have some different links here. So if you have to pause or rewind, then go ahead and do that. I didn't want you to have to do the Kami version of this just because you needed to be able to look at a spreadsheet and see the data. So I figured doing this Desmos activity would be the easiest because it already had the links that you needed to click on. So on this one, it says use technology to find the mean and the standard deviation for the data in the data plots. So looking at this, there is one value, one dot on every number from 1 to 10. So I'm going to click on Desmos, and it's dot plot 1 that I'm looking at. And remember, we said there is a data value on every number except from 1 to 10. So you would just do 1, 2, 3, and you would input all of these numbers. If you just want to watch this part and then go back and put the statistics, that is fine too, because I know this is a lot of clicking and different things. So what we're looking at is our mean is 5.5. Our standard deviation is 2.87. So we would go back. So you would just click on your other tab. Your mean was 5.5. And if you forget, you can just click back on this because I forget. And 2.87 was the standard deviation. So we'll go here and type in standard deviation, and we have a check mark. Then you're going to go to dot plot 2. Again, you can watch this part instead of clicking back and forth if you would like. This has two values on 10, 20, 30, 40, 50. So I'm going to go to dot plot 2, and I'm going to type 10, 10, and then 20, 20, and so on all the way to 50. So I have all those, and then our mean is 30, and our standard deviation is 14.14. So I've got to go back and find that. So mean was 30, and standard deviation was 14.14. Again, you do not have to keep up with this part. If you want to just watch what I'm doing and then put the statistics in the blanks, that would be perfectly fine. All right, so look at this last one. All the numbers are on 2. So what is our mean going to be? Our mean is going to be 2. What about our standard deviation? Is there any variability going on here? There's not, so it should be 0. But we're going to go ahead and type it in 2. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 2s. So, whoops, not that. So I'm going to click on dot plot 3, and I'm going to type in 10 2s. All right, so we have 10. Our mean is 2, and our standard deviation, as we said, was 0. Okay, so that's all for that part. Then we're going to go to next. Now it's saying we have 3 more dot plots. We have 4, 5, and 6. So we're going to go ahead and do these. We have 1 dot on all of those from -9 all the way to 0. So So I'm going to click on that. -9, -8, -7, -6, -5, -4, -3, -2, -1, and 0. Our mean is -4.5 and our standard deviation is 2.87. So -4.5 and 2.87. Okay, and then dot plot 2. We have two numbers on 5, 10, 15, 20, and 25. Again, you do not have to keep up with this part. You can simply watch and then put in the summary statistics. Whoops, that's not right. Okay, so I have 10 element list. My mean is 15 and my standard deviation is 7.07. Okay, and then we have the last one where we have all of our data values on -3 and 7. 2, 3, 4. So it looks like 5 and 5. So we have -3 and 7. And so our mean is 2 and our standard deviation is 5. So our mean is 2 and standard deviation is 5. So now we have all of those filled in. And we're going to go to the next part. Okay, so now we're on this and we have all of these where we filled in from the last part. So if you filled them all in, then they would carry over to the next screen. So what do you notice about the mean and the standard deviation you found for the 6 dot plots? Are any of the standard deviations the same? Are any of the means the same? So looking at, you have for dot plot 3 and dot plot 6, you had the same mean of 2. Okay, look at dot plot 1 and dot plot 4. So here's 1 and here's 4. Your standard deviation was the same. Notice how these are only 1 apart. These are also negative, so 1 through 10 were 1 apart, -9 through 0. All of those dots were just 1 value apart. So, standard deviation is measuring how widespread the data is. Look at dot plot 2 and dot plot 5. So dot plot 2 had 10, 20, 30, 40, 50. Dot plot 5 had 5, 10, 15, 20, 25. And look at those standard deviations. You have 14.14 and 7.07. 7.07 is just half of 14.14. So that's kind of interesting how you had 10, 20, 30, 40, 50, and then when you went by 5s, 5, 10, 15, 20, 25, the standard deviation ended up being half of that first one. Okay, so we can talk about this. So for the first dot plot, your standard deviations were the same for number 1 and number 4 because the data values are distributed the same way. And then we talked about 2 and 5 and how they're spread out differently. So they're going by 10s, and then the other dot plot 5 is going by 5s. And then on the last one, so on number 3 and number 6, you have on number 3, they were all the same value, so the standard deviation was 0. But if you look at number 6, dot plot 6, they went from -3 to 7, so the standard deviation was higher. They were more spread out than they were on dot plot 3. So I'm just going to give you some different things you could have typed as I was talking. So let's just say for the first dot plot, and if you wrote something else down already, that's fine. Leave it. I can look at that after you submit it. The standard deviation is the same because the data values are distributed the same way around the mean. For the second dot plot, so we're looking at the second dot plot for each group. So you typically would have done these in groups, but for the second dot plot, so this is number 2 and 5, the standard deviation is greater for dot plot 2 than it is for dot plot 5, because the data are spread further apart. So on number 2 it's going by tens, and number 5 it's going by fives. And then for the third dot plot, can't spell, the standard deviation is greater for dot plot 6 because there is some variation in the data. Because on dot plot 3, there was no variation. So dot plot 6, there was. So if you're comparing number 3 and number 6 did have some variation. The standard deviation was greater. Okay, again, you can pause if you're still trying to type, and then push play again when you're ready. All right, we're going to continue on. So this one says, create a data set of 10 numbers with a standard deviation equal to the standard deviation of your first dot plot, which was like 2.87, with a mean of 6. So it says, hint, you may want to look back at the first dot plot to make this way easier. So I still have these up here, so I'm going to go back and look at that first dot plot, if I can find it. And it was where all the numbers were on 1 through 10. So to start out, that's what I'm going to do. I'm going to type all of those numbers again. And we're just going to look at the statistics again. So we have a mean of 5.5 and a standard deviation of 2.87. Now, they want a mean of 6, but we want to keep the same standard deviation. So we know that our numbers have got to come up some. I'm only half away from 6. So 5.5 to 6 is only half. So, because if I go back here, and let's say I do 2, 3, 4, 5, change them all. We're going to go up by 1 on all of them. 8, 9, 10. I'm going to change this one to 11. Now look what happens. We still have the same standard deviation, but our mean is up 6.5. So we went too far. So what is in between 1 and 2? We would have 1.5. So let's go back a half. So 2.5, 3.5, 4.5, 5.5, 6.5, 7.5, 8.5, 9.5, and we're going to go back to 10.5, and let's see what happens. So look, our mean is now 6. Our standard deviation stayed the same at 2.87 because we still have these numbers just one apart from each other. So that worked. So those would be for those. So then we're just going to click next and go to the next one. Now they say create a data set of 10 numbers with a standard deviation 3 times greater than the data in the first row. So here's my data in the first row. We have 1 through 10, and our standard deviation was 2.87, so we got 3 times that. So it doesn't say anything about what the mean has to be. It just says the standard deviation has to be 3 times greater. So if we need our standard deviation to be higher, we have got to spread our numbers out. So let's do, I'm just guessing here. Let's do 1, 4, 7. Let's see what happens. So this gives us 3.35, but that's still not far enough. We've got to go further than that. So let's do 1, 9, 15, 20. That's given us, let's see. 29. It's kind of a little higher. So we still got to go back and 35. I'm just randomly throwing out numbers here. 38. Let's see. So we have 1, 2, 3, 4, 5, 6, 7, 39, 40, 41. Okay, so that's 10 numbers. But what's going on is my standard deviation is 13.7. So I need to make this number a little bit larger. It's still 13.03, so let's do like 10. Okay, that brings it down to 12. Let's make this 11. Let's go ahead and make this one 14. Make this one 16. So I'm at 10.7. So I'm trying to get these numbers a little bit closer. So let's take this 41 and let's back it up to like 37. Whoops. Okay, so that brought me down to 10. Let's go ahead and back it up to like 34. Still not much better. We need to back this 40 up to, let's say, 37. Let's see what happens there. Okay, so now I'm at 9.79. So I'm getting closer. So I'm just trying to get these numbers a little bit closer together. So let's take this 14 and bring it up to 17. So that's even closer. So I'm just trying to close that gap a little bit. Let's do this one and make it 18. Okay, so we're at 9. So we're getting even closer. Let's do this 16 and let's make it 19. Okay, so now we're at 8.66. We are so close. So let's go back and make this 17.5 and see what happens. Okay, so 8.83, so it actually took us back a little bit. Let's make this one 18.5. So that's 18.78. So we are literally a tenth away. So we need to go a little bit closer. So let's do 18.6. Okay, so that gave us 7.6. Let's do 17.6. Gave us 7.5. Let's do 17.2. Let's back that up and do 3. Getting closer. 4, 5, 6. Okay, so that's 8.679. So if we rounded to the nearest hundredth, we would have 8.68. So notice at first, standard deviation was larger. So as we had to bring those numbers back down, we had to play around with that and get them closer and closer in order to get that standard deviation the way we wanted it. So, all right, so let's go to the next one. So what do you think that standard deviation measures? I want you to put what you think here. I've talked about it all through this video, so I want you to see if you've retained that and type that in this box. What do you think standard deviation measures? I'm going to go ahead and go to next. You can pause if you're still thinking. All right, so look at this. Why is the standard deviation the same for 1, 2, 3, 4, 5? And then if we had a red dot plot, I wonder if it has it. If we had a red dot plot under, oh wait, it's right here, sorry. At -2, -1, 0, 1, and 2. So why do you think the standard deviation would be the same for these two? What do you think? So type what you think there. Why do you think the standard deviation would be the same? All right. Well, if you notice, these are all the same distance apart. So the blue dots are going by ones. Well, these are also going by ones. They're just starting in a different place, but they're all going by, they're the same distance apart. All of the data values are the same distance apart. So all of the data values are the same distance apart. That's it. Okay. Why is the standard deviation different for this one? We have -4, -2, 0, 2, and 4. And then we have -4, -3, -2, -1, 0. So why is it different for these? Well, if you look, these are one apart. I'm sorry, these are two apart. -4, -2, 0, 2, and 4. And these are only one apart. So it's going to be different. So the data values are not the same distance apart for each dot plot. So you're going to have a different standard deviation for those. All right, look at this one. When is the standard deviation equal to 0? Type what you think here. I shouldn't have to tell you what this is. When is the standard deviation equal to 0? So this one right here, we have all these values at 2. Our standard deviation is 0, and we've talked about this. So go ahead and do that. All right, so here is another part. You are going to click this link and type in this data. It says, begin with this data. It's taking a little bit of time. And they want to know, what is the mean of the data set? What is the standard deviation? What is the median? And what is the interquartile range? Well, they already have the data here for you, and they already have the summary statistics. So all you have to do is look at this. Okay, it says our mean is 10.5. So you would come here, type in your mean. Standard deviation is right here. We're going to do 5.77. I just rounded it. What is the median? So go back. It tells you that. It's 10.5. And what is the interquartile range? Well, it tells you that too. Q3 minus Q1 is going to be 10. So all of those data values, that's all you had to do. So you could have watched mine. You could have clicked and looked as yourself as well, but it's fine if you're just watching this video and typing in what I'm typing in. Okay, so on this one, same thing. We have another dot plot. They want to know what is all the information. So it looks the same, 10.5, 5.77, 10.5 median, and the interquartile range is the same as well. So 10.5. And I think it goes to 1 to 15. All of the data values are the same too, so I'm not really sure about that. So 10.5. Oh wait, did I type in something wrong? 10.5. I'm going to X off of this. And we're going to go back and click it again. Yeah, the mean is 10.5. But it's telling me there's an X, so... Oh, I know what it's saying. Okay, so it's saying, how did the standard deviation and mean change when you remove the greatest value 20 from the data set? Oh, so we've got to go here, and we've got to go all the way over to 20 and remove it. So now we have the mean is 10. That's why. So if you get it wrong, it gives you an X. The standard deviation is 5.48 if we round. The median is also 10, and the IQR is still 10. All right, so that's how did it change? We have those new statistics there. Notice our mean decreased, our median and our IQR stayed the same. Okay, so How do the standard deviation and mean change if you add a value to the data set that is twice the greatest value? So if we add 40 to the data set, so we're going to go to this, and we're going to go over here, and we're going to add 40 to the data set. All right, so our mean is 11.5. Our standard deviation is 8.44. Our median is 10.5. Oh, it's telling me wrong, so I must have done something wrong. Hold on. Let me go back. Maybe I needed to keep 20 and then go ahead and put 40 also. So let's try this. 11.9. Let's see what it gives me here. Okay, that's what it's supposed to do. So let's go back and fix that. So our standard deviation is 8.43. Our median is 11, and our IQR is 11. Okay. And then what do you predict will happen to the standard deviation and mean when you remove the least value from the data set? So go ahead and type what you predict. Type what you predict here, and then you're going to see if it happened. So type what you predict. Well, we remove the least value. So you're looking at this and you remove the least value. So what do you think is going to happen? You have all of these 20 numbers here, and if I take away the smallest number, what do I think is going to happen? All right, so I'm going to delete the smallest number, and you have to take away the comma also. So now your mean is 11, your standard deviation is 5.48, your median is 11, and your Q3 minus Q1 is 10. So if you predicted that the mean would increase and the standard deviation would decrease, so our mean, we went from, what was our mean before? We can go to previous. Our mean was 11.9, and now we just said it's at 11, so it did decrease. Wait, maybe we need to look at our original. Let me see. Is this our original? It would have been when we had 20 here. Okay, so our mean was 10.5, but now when you take out the least data value, your mean is 11. So your mean does increase. The standard deviation is 5.48. What was it? The original, it was 5.77. So yes, your standard deviation also decreased, or it did decrease. Your mean increased, your standard deviation decreased when that least value was removed. All right, so then you would answer those two. What appears to change more easily, the standard deviation or the interquartile range? So looking at those, what changes more easily? It should be the standard deviation. If you chose that, then you explain why you think the standard deviation changes more easily. I want you to do that on your own. Okay, what does the standard deviation measure? We talked about this all through this lesson also, so I want you to type what the standard deviation measures. All right, the standard deviation is calculated, and you can pause if you need to keep typing there. It's calculated using the mean. Do you think it is more appropriate to use with symmetric or skewed data sets? Remember when we use mean. We use mean with symmetric data sets. We use median with non-symmetric or skewed. So if we use mean with symmetric and we have to use mean to calculate standard deviation, then we need to use standard deviation with symmetric data sets. It's very important. How does standard deviation compare and contrast with mean absolute deviation and IQR. So I want you to type what you think there about that. How do they contrast, compare and contrast with mean absolute deviation and IQR? Okay, well, how does it compare? The standard deviation measures variability. MAD and IQR also measure variability. So they all three measure variability. But standard deviation, so unlike IQR, standard deviation is based on the mean and not the median. So IQR, is based on that median. We do Q3 minus Q1. Standard deviation is very similar to mean absolute deviation because it involves finding the difference of each value and the mean, but then you perform different operations. So standard deviation is very similar to mean absolute deviation. You use the mean to calculate both. Use the mean to calculate standard deviation and mean absolute deviation. All right, so if you need to pause so you can get all that in there, this is important. If you want to write on your notebook paper, take notes on this part or all of this stuff, or maybe at home when you have extra time, all of this stuff is important. So we need to be retaining that so that we can be prepared for our assessments. Okay, so one data set has a standard deviation of 5, and another data set has a standard deviation of 10. What does this tell you about the distribution of each data set? Remember, standard deviation calculates variability, how widespread the data is. So if I have a data set that has a standard deviation of 5, and then I have another data set that's standard deviation of 10, that data set with the standard deviation of 10 is going to be more spread out than the one with the standard deviation of 5. So the data set with the standard deviation of 10 is going to have data that is more spread out than the data set with the standard deviation of 5. That makes sense. The data set with the standard deviation of 10 is going to have data that is more spread out than the data set with a standard deviation of 5, because that means those numbers are closer together. If I have a standard deviation of 5, my numbers are closer together than they are if I have a standard deviation of 10. All right, so now you're at the cool down. So I want you to do this on your own. The low temperature in degrees Celsius for some cities on the same days in March are recorded in the dot plots. It's asking you true or false. The standard deviation of Christchurch's temperatures is 0 because the data is symmetric. So they're looking at this first dot plot and they're saying the standard deviation is 0 because the data is symmetric. So you would choose true or false there. Then there's some more. The low temperature is same thing. The standard deviation of St. Louis's temperature is equal to the standard deviation of Chicago's temperature. So St. Louis is the second one. Chicago is the third one. So they're saying, are they equal, true or false? You can pause so you can have time to think. And then the last one, the standard deviation of Chicago's temperature is less than the standard deviation of London's temperature. So Chicago is the third one. It's saying the standard deviation is less than the standard deviation of this last one, London. So you would answer true or false on those. Okay, so I hope this lesson has helped you understand more about standard deviation and comparing the variability of those. So remember, reach out if you have any questions, and I will be happy to help you.